There are many solutions on cubic equation. In this video, we will introduce a method from Wei Dongyi. It is a kind of variable substitution method. Example 1. X cubed minus 3x plus 1 equal to 0. This is a very simple, looks like. If there is a rational root, the root can only be 1 or 2, based on Gauss lemma. But f1, we can see f1 is minus 1, and f minus 1, it will be 3. So they are not 0. So 1 and minus 1 are not root. Obviously, it doesn't have a rational root, and cannot be solved using normal polynomial factorization method. However, f0 greater than 0, f1 less than 0, so there exists a real root in 0, 1 period. How to solve the problem using Wei Dongyi's method? And we don't use polynomial factorization. We let x equal to a plus k divided by a. K is a constant. Here, we select k equal to 1, and then we have x equal to a plus 1 divided by a. Here, a is a variable. And we put a inside. It becomes 1 plus a plus 1 divided by a. 3 minus 3, a plus 1 divided by a plus 1 equal to 0. And it is a3, 3, a squared, 3a squared plus minus 3a minus 3 divided by a plus 1 equal to 0. And this is a cube, 3a, 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 3 divided by a plus 1 equal to 0. And you can see 3a and 3 can be cut off. 3a, 3 can be cut off. And it becomes a very simple equation. Obviously, this equation can be solved immediately if we set y equal to a3. And we can immediately get the result. We get two plural numbers. Before we go too further on the detail on solving this problem, people may ask, how do you know k is equal to 1? And suppose this is not minus 3, this is minus 4, this is 6. How do you get it? How do you use this method? We will show how we get k is equal to 1 for this problem, and then in some other examples, we will change 3 to some different numbers, and also we will have some x squared, and to see how to solve the problems in some other examples. So when it is 1, say we don't know if k is equal to 1, then we will use this way. A plus k divided by a, 3, minus 3, a plus k divided by a plus 1 equal to 0. And the same way, a3 plus a2k, a plus 3a k divided by a squared plus k divided by a cubed plus minus 3a minus 3k divided by a plus 1 equal to 0. And we get 3ak plus 3k squared a plus k a cubed minus 3a minus 3k divided by a plus 1 equal to 0. And we see for this item and this item, we put them together, so it becomes a cube plus 3a k minus 1. And divided by a, we put them together. And for the others, we put them in the last. Here, we can see only if k equal to 1, the item about a divided by a will become 0, and the equation becomes simple. So that's why we select k is equal to 1. Before we go to more complicated and samples, let us finish this first example first. Say y is equal to a cube. We select y1 first, so we use y1. And y1 is the same as cosine 2 3 pi plus I sine 2 3 pi. And it is the same I 2 3 pi plus 2n pi. Here, an is a number, or integer. Because a has 3 roots, so we select n is equal to 0, 1, and 2, and we get 3a value, 3 roots of a separately. Because x is equal to a plus 1 divided by a, from the first one, we can think e 2 pi divided by 9i plus 1 divided by a, it is e minus 2 pi divided by 9i, and this becomes 2 cosine 2 divided by 9 pi. That's from the first. So this is x1. Same thing, x2 is 2 cosine 8 pi divided by 9. And x3 is 2 cosine 14 pi divided by 9. So we get 3 roots of x. Someone may think, from y1 you get 3 roots, and from y2 you may get another 3 roots. How come you get 6 roots for cube equations? Okay, let us to see what we will get from y2. And same thing, y2 is cosine minus 2 divided by 3 pi minus 2 pi 3. And this is e minus 2 divided by 3 pi I. And same as minus 2 divided by 3 pi plus 2n pi I. Here n is an integer. Same thing, we select 3 different numbers for n, and we will get 3 roots of a. So when n is minus 1, we get this result. And n is minus 2, we get this result. So we get 3 x value for y2. Take a close look. We find the first one, cosine 4 pi divided by 9. It is actually the same as the last one, cosine 14 pi divided by 9. Because 4 divided by 9 pi plus 14 pi divided by 9, it is 2 pi. So the number, the cosine number is the same. So this one is the same as this one. And this one is the same as this one. The middle one is also the same. So only 3 roots exist. Okay, let's see another example. Here it is 6 instead of 3, but we can make some change to make it to be 3. So we let x equal to k, x dot. And here k is a constant, and x dot is a variable. And we have kx dot cube minus c kx dot plus 1 equal to 0. X dot cube minus 6 divided by k square x dot plus 1 divided by k cube 0 equal to 0. And we want to make 6 divided by k square equal to 3. So we can select k is equal to root 2. And this equation is changed to like this. So we can see here it is a 3. In this case, we can use the same way that x dot equal to a plus 1 divided by a. If we put this into the equation, we will immediately get a cube plus 1 divided by a cube plus 1 divided by 2 root 2 equal to 0. And we can let y equal to a cube. And we can get the result. The third example. Here it is not minus 3, but it is plus 3. How to do it? We can use a similar way. Let x equal to a minus 1 divided by a. So here it is not a plus, but use a minus. And then we put it inside. We will get the same thing. Plus 3a minus 1 divided by a plus 1 equal to 0. And a3, 3a square, 3a 1 divided by a square minus cube plus 3a 3 divided by a plus 1 equal to 0. And same thing, 3a is off. And 3 divided by a is off. So we will get a cube minus 1 divided by a cube plus 1 equal to 0. This is also very easy function, easy equation to be solved. Let's see the next example. Here it is a square over here. We need to eliminate the x square item. So we let x equal to x dot plus k. And x dot plus k cube plus 3 x dot plus k square minus 1. And we have cube 3 square equal to 0. So x dot square, to make it to be 0, so we have 3k plus 3 equal to 0, means k equal to minus 1. So we can let x equal to x dot minus 1 and put it inside, and the equation will be changed to x dot square 3x dot k square is 1 and minus 1 plus 6x dot k is minus 1 plus 3 minus 1 equal to 0. And we find it changed to the first problem. So this problem is changed to the first problem. It is solved. Let us see the general case. So the ABC can be any number. It is a cubic equation. How to solve it? First, we need to eliminate the x square item. So we set x equal to x dot minus a divided by 3 and put it inside. We have x dot minus a divided by 3 cube plus a x dot minus a divided by 3 square plus b x dot minus a divided by 3 plus c equal to 0. We need x dot square item to be 0. Then x dot cube square a divided by 3 plus 3 a divided by 3 square minus a divided by 3 cube plus ab divided by 3 plus c equal to 0. We take a close look. You can see the x square item is minus ax dot square, and here it is plus ax dot square, so it can be cut off. So only cube and x dot item exist, and this is our favorite. So we combine two related items, and we get this equation. We let p equal to b minus a squared divided by 3, and q equal to blah blah. And we get x dot cube plus p x dot plus q equal to 0. Here, if b is greater than a square divided by 3, we set p equal to b minus a square divided by 3, and we use this function. And if b less than a square divided by 3, we will let p equal to a square divided by 3 minus b. So the p is always greater than 0. And the equation becomes x cube minus px dot plus q equal to 0. So we have two. One is plus q, p, one is minus p in two cases. As an example, let we focus on case 1, and case 2 can be solved using the same way. We can use the parameter extension method as we said in sample 2. So we let x dot equal to ky, and then ky cube plus p ky plus q equal to 0, and y cube plus p divided by k square y plus q divided by k cube equal to 0. And we need p divided by k square equal to 3, so we get k is equal to root p divided by 3. So the equation becomes y cube plus 3y plus q divided by p divided by 3 cube equal to 0. Obviously, this can be easy to be solved. We let u equal to u minus 1 divided by u, and we will get u cube minus 1 divided by u cube plus q divided by 3 cube equal to 0. The problem is solved. Same thing for case 2. K is still equal to root p divided by 3. But y will be u plus 1 divided by u, and the last function will become u cube plus. So everything is the same. Only this is plus. The case 1 is minus. In a word, for any cubic equations, you can use Weidong-Yi's method to solve the problem. This is the first section. In next lectures, we will use some other method to solve cubic equations, and some methods are very useful and efficient.